Our next slide has the definition of parallel lines. Parallel lines are lines that do not intersect or have any points in common. Parallel lines have slopes that are equal. So on any question in the book, if they wanted to know if two lines are parallel, all I would have to do is determine a slope. If I'm given 2 points for each line, I would determine a slope by the slope formula. Or if I'm given a diagram, all I would have to do is to determine the slope. I know that both of these lines are decreasing from left to right, so I know both of them are negative. Here, it looks like an intersection point for whole numbers for my ordered pairs, 0, 0. The next one would be over here, which looks like at a negative 3, 1. All I would have to do is actually count. Here, I'm going to have 3 over and down 1. So that would be 3, 1. Or I could also go down 1 and over 3. Either way, the slope for line A is going to be a negative, because it's decreasing from left to right, rise over run. So this would be a negative 1/3. Now, if we do the similar situation for B, it looks like I'm intersecting here and also here. And I count down 1, over 3. Similarly, I could count over 3 and down 1. Either case, I get a rise of 1 and I get a run of 3. So my slope of line B, rise over run, is 1/3. Since my line is decreasing from left to right, it is also negative. Now I realize that my slope for A and B are equal. Therefore, I know that line A and B are parallel. And this is the symbol for parallelism. Line A is parallel to line B. Our next slide has the definition of perpendicular lines. Here, perpendicular lines are lines that intersect to form right angles, that is, 90-degree right angles. Perpendicular lines have slopes that are negative reciprocals of each other. So again, if I was given a problem in the book and I had 2 points, all I'd have to do is to figure out the slope by using the slope formula. And if they turned out to be negative reciprocals, they would be perpendicular lines. Here, I'm given a diagram. Similarly, on the other page, I had to determine the slope. So let's determine the slope, and I'll call this line A. My intersection point looks to be about here, another one here. So when I count, I can go up 1 and over 1, 2, 3. Also, I can go over 3 and up 1. And I know the slope of line A is rise over run, which is 1 over 3. And this line increases from left to right, therefore it is positive. I'll call this line B. Again, I have an intersection point here, and it looks like I have another one here. I can count down 1, 2, 3, and over 1, or up 1, 2, 3, and over 1. Either case, I get a rise of 3 and a run of 1. For the slope of B, I'll have a rise of 3 and a run of 1. Rise over run is 3 over 1. My line B is decreasing from left to right, therefore it is negative. And by definition, my perpendicular lines have slopes that are negative reciprocals. Here I have 1/3. The reciprocal is 3 over 1. This one's positive. This one's negative. Therefore, that fits my definition. And I know that line A and B are perpendicular. This is my symbol for perpendicularity. So line A is perpendicular to line B. Therefore, I know that these lines must intersect to form right angles. Next, what we want to do is to look at the procedure to write parallel and perpendicular equations of lines. Step 1, solve the given equation for y to determine the slope. Step 2, use the slope of the line for parallel or negative reciprocal for perpendicular. 3, substitute the needed slope and point into the point slope formula. 4, solve for y. And 5, graph if needed. So we want to write an equation of a line that passes through this point, but is parallel to this given equation. This equation is already solved for y, therefore I know the slope is 3. If I want a parallel line, I want to use the slope of 3. If it was a perpendicular line, I would want to find the reciprocal and then make this negative, so that would be a negative 1/3. But since it's parallel, I'm going to use the slope. So I'm going to use the point and that slope into the point slope formula, which is y minus y1 equals m times x minus x1. Substituting, we know that this is x, this is y. And when I do that, I'm going to get y minus 3 equals m, which is 3, times x minus 3. Solving for y, let's simplify first. Y minus 3 equals, when I distribute, 3x minus 9. We solve for y by adding 3 on both sides. Y equals 3x minus 6. Let's graph both of these. Here I know my slope is 3 and my intercept is 0, negative 2. That's going to give me 0, negative 2, and then I count the slope. Since it's positive, I'll go up 1, 2, 3, and over 1. Again, up 1, 2, 3, and over 1. Connect to 3 points. Graphing the other line, I know I have a slope of 3 and a y-intercept of 0, negative 6. 1, 2, 3, 4, 5, 6. My slope is positive, so I'm going to go up 3. 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. And another set, 1, 2, 3 over 1. Connect the points. And there are my two parallel lines. And I know that because my slopes are equal. Our next example, we want to write an equation that passes through 2, negative 3, and is parallel to my given line. Therefore, I want to use the slope of 4 because I want them to be parallel. I'll substitute this point, being x1 and y1, into my point slope formula, y minus y1 equals m times x minus x1. Substituting y minus y1 is negative 3. M is 4. X minus x1, which is going to be 2. Then we simplify and solve for y. Y plus 3 equals 4x minus 8. Subtract 3 on both sides. That gives me y equal to 4x minus 11. Here, my slope is 4 with a y-intercept of 0, negative 11. And I know my equations are parallel because here my slope is 4. And this one has a y-intercept of a positive 0, 1. I could graph both of these. 0, 1 is my y-intercept. Then up 4, 1, 2, 3, 4. It's positive, so I went up and over to the right 1. Up 1, 2, 3, 4, and over 1. And connecting the points. Similarly with 0, negative 11. It's a little off my chart, which is approximately here. And then still up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And again, connecting the points. I know these two lines are parallel because their slopes are equal. Here they want us to write an equation of a line that passes through 2, negative 3, but is perpendicular to my given equation. So here my slope is m equals 4. But since I want this to be perpendicular, I need to have a slope that would be the negative reciprocal of this line. Therefore, a negative reciprocal would be 1 over 4. And since this is positive, I will make that negative. Then I use this given slope and that point, being x1, y1, into the point slope formula. Y minus y1 equals m times x minus x1. Substituting y minus y1, which is going to be a negative 3. Negative and a negative is a positive 3. My slope, since it's perpendicular, is going to be a negative 1/4. X minus x1, which is a 2. Simplifying, y plus 3 equals a negative 1/4 x plus a negative times a negative is 1 times 2 is 2. Positive 2 over 4 is a positive 1/2. Let's multiply both sides by the least common denominator to eliminate fractions. That's going to be multiplying by 4. That's going to give me 4y plus 12 equals 4 times a negative 1 is a negative 4 divided by 4 is going to give me a negative x. 4 times a positive 1 is a positive 4 over 2, which is a positive 2. Solving for y, let's subtract 12 on both sides. Gives me 4y equals a negative x minus 10. Dividing by 4, and 4 has to go into each term, whether it goes in evenly or not, gives me y equal to a negative 1/4 x minus 10 divided by 4 is going to be simplifying. 2 goes in each, 5/2. So my slope on this equation is a negative 1/4, and my y-intercept is 0, negative 2.5. And I know that these are perpendicular lines because my slope here is 4. The negative reciprocal of this equation has a slope of a negative 1/4. I could graph both. Here, my y-intercept is 0, 1. So 0, 1. Here, my slope is 4 over 1, so I go up 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. I know I'm off the graph, but that's just an estimate. Graphing this equation and its slope and y-intercept, 0, negative 2.5. And its slope is going to be a negative 1/4. So I'm going to go down 1, since it's negative, and over 1, 2, 3, 4. Down 1 and over 1, 2, 3, 4. And there's my 3 points. Not being a perfect graph, of course we're doing it by hand, I do know that these two lines are perpendicular and form right angles because their slopes are negative reciprocals. On our previous 3 examples, we found equations perpendicular and parallel to a given equation, but had to pass through the point that was given. So here we can find 2, negative 3, and it did pass through it. Again, this one had to be 2, negative 3, and again, it did pass through. Similarly, on the first one, we had to pass through 3, 3. So knowing that we are following the correct procedure, we want to find our last example, an equation that passes through 2, 4, but is perpendicular to our given equation of y equals 3. Here, if we recall, y equaling 3 is going to give us a horizontal line at the value of y equaling 3. So here I know that my m is 0. Therefore, I know if I need a perpendicular line, I need a slope that is undefined. And with a slope that's undefined, I know I need a vertical line. Therefore, a vertical line is only going to intersect with my x-axis. So I need to use the value that is given here, which is a value of x equal to 2. Therefore, my equation that is going to have an undefined slope is x equal to 2. And I can graph that in a similar fashion as our y equals 3. So here is our right angle. This one has a slope of 0. This one has a slope that is undefined. If I wanted something that was parallel to y equals 3, I could use the y value of 4 and just graph that. Again, this line passes through 2, 4.